All right, so we want to look at solving some exponential equations like we were doing the other time in the last class. Remember, the key thing here, whenever we are solving these exponential equations, is finding the common base. So between 16 and 32, what's the common base that we have for them? Now remember, whatever you think of, you should be able to raise that number to a power to get 16. Well, it's 1 over 16, but we'll make the correction for that here in a moment. And you need to also be able to take that number and raise it to a power to get 32. So what is a base that these guys have in common?
16.
Well, you could say 16, but what power of 16 gives you 32? Because see, 16 to the first is 16, but then 16 to the second is 256. We need to be able to find a base that's common for both 16 and 32.
So 2?
It's going to be 2. You might think 4, because 4 squared is 16, right? But 4 to the third is 64. So then you're kind of stuck in this nowhere, this no man's land for that. If you go to 2, and you think about this off to the side, 2 to the 4th power, so you've got to know your powers. I gave you that sheet at the beginning of the semester. 2 to the 4th is 16, and 2 to the 5th power is 32. So using this, we can rewrite these expressions with a base of 2. Now here's the trick that we have to watch out for. 16 would be 2 to the 4th, but what kind of power leads you to a fraction? If you think back to a long time ago, negative powers will lead to fractions like this. So 2 to the 4th itself would be 16, but just so that you understand, if I do 2 to the negative 4th, that would be 2 over 4, which equals, 1 over 2 to the 4th, which equals 1 over 16. And so that's what we're thinking about. If you can find how you would rewrite the 16 as 2 to the 4th, then since it's 1 over, you've got to make it 2 to the negative 4th. And this is raised to the 7x minus 2 power. On the right side, 32, there's no fuss here. That's just 2 to the 5th power. And then you get raised to the 19 minus 6x power. And as we were doing these the other day, we know that when you have a power raised to a power, what are you going to do with these guys? You got to multiply them, right? You're going to do that on both sides. So you've got two options here. You could go ahead and multiply these guys in the power and then say, okay, I've got the same base. You could also just kind of rewrite this and say right now that since these bases are the same, so since we have the same base, and we know that we need to multiply these powers, maybe we just rewrite it like this. Negative 4 times 7x minus 2 on the left equals 5 times 19 minus 6x on the right. Okay. So you might kind of think that I'm skipping a step here. I know that since I have the same base, those guys are going to, we're not going to worry about that, we're just going to worry about the powers. And we also know that powers to powers will multiply like this. Once you get here, this goes back to the first week of this semester, or even several years ago, back when you were just still knee-high to a grasshopper. You know how to solve something like this. What would you do first? You got to distribute. So this is negative 28x plus 8 on the left side, distribute the 5 on the right, and we have 95 minus 30x. This is just a simple linear equation. You know what to do with these guys. You get x's on one side, you get your constants on the other, and so what's the quickest, simplest, easiest way of doing that? Right, I would add 30x over to the left side because that now makes it my variable term with a positive coefficient. That should make things easier for me. Variables come to the left, constants need to go to the right, so I'm going to subtract 8 on both sides. And now everybody should be happy. So we get 2x is equal to 95 minus 8, which is 87. And that means that x equals what when we finish? 87 divided by 2. What do you guys think? Now, let's go on and look at one that's slightly different, that might have a bit of a trick to it. But again, all the tricks that we might see here in these equations all come down to knowing how to work with powers, how to rewrite and see things from a slightly different perspective. All right? So the next one we want to look at is the fifth root of 25 is equal to 125 raised to the 2x plus 9. Don't worry about the powers that you see here. Don't worry about the radical. Your focus needs to be on the bases. The bases here are 25 and 125. What's their common base? What are they both built from? 5s, right? And so we know here that I can rewrite 25 as 5 squared, so we're going to start with that. And the 125 is 5 to the third. Okay, simple enough. Now, I'm going to rewrite this and say this is the fifth root. 25 is 5 squared. And on the right side, I'm going to rewrite 125 to be 5 to the third, just what you guys were telling me. And this is where things get a little bit dicey, and it comes down here to this radical. One of the things that you need to make sure that you remember is this. When you have the nth root of a number, you can rewrite that to say x to the 1 over n power. Okay? And these guys kind of go back and forth. The key thing here to remember is that the index of your radical becomes the denominator of your power. So that means I can rewrite this and say this is 5 raised to the second, and what do I do with the 5? Where's the index go? It goes in the denominator of the power, so 5 to the 2 over 5. Right? So you still have the 5 squared for the 25. The denominator of 5 right here matches up and corresponds to the index of your radical. And on the right side, power to a power means that I multiply. So we get 5 raised to the 6x plus 27. And again, it's all about finding that common base. These guys have a common base of 5. So what can we say next? Right, so since we have the bases to be equal, that means the powers must also be equal. So 2 over 5 is equal to 6x plus 27. There shouldn't be a problem finishing this, and I guarantee that you will see something like this on your next exam. The easiest way to handle this is to clear out the fractions. And how do we clear fractions? Well, you want to find the LCD. In this case, it's 5. And you multiply both sides of the equation by that LCD. So I'm going to multiply both sides times 5. By doing it this way, on the left side, the 5s reduce. We just get 2. And then on the right side, we distribute. So 5 times 6x is 30x. And 5 times 27 is 135. And where do we go from here? How do I solve? Right, so the thing that I need you guys to remember, is this. Forget everything that you had before that. You're here. This is a nice linear equation. There are no tricks. You don't have to worry about, I've got to worry about completing the square and I need to have an even number. You don't have to worry about a plus or minus from doing the square root property. You don't have to split it up into 2 equations. This is a nice linear equation. From here, we shouldn't have any problems, right? Don't get thrown off by the fact that it came from something that was exponential. I don't care. Once you get here, once you're out of that exponential form, you get back to your hometown. You get back to where you know everybody. Where you're going to Walmart and everybody asks how you're doing, how's your family doing? And you're like, I just wanted to get a new pair of socks. Yeah?
So when you said that n of x is equal to x.
To the 1 over n.
So where did you get 2 from? So for this
Well, this 2 right here is that 2. You can't lose that power, right? And if you look at over here, this is understood to be x to the first, and so that's the one that you see right there. So coming back to finish this problem, this is negative 133 is equal to 30x. We divide both sides by 30. So x, now completely by itself, is negative 133 over 30. You would try to reduce that fraction, but it's not going to work. There's going to be nothing in common whatsoever. Okay. But again, you want to see if it does reduce. And there we go.